Welcome to the DIY Honda Garage channel. In this presentation, we will focus on Diagnostic Trouble Code DTC P2422, which indicates an issue with the EVAP canister vent shut valve in the Honda Civic models ranging from 2016 to 2021. Understanding this code is essential for diagnosing potential malfunctions in the vehicle's emission control system. The DTC is activated when the valve is stuck closed, preventing necessary evaporation of fuel vapors, which could lead to increased emissions and suboptimal engine performance. The evaporative emission system, EVAP, plays a vital role in capturing and recycling fuel vapors that could otherwise escape into the atmosphere. By analyzing the components involved and diagnosing the issue accurately, we can ensure that the vehicle meets environmental regulations and operates efficiently. DTC P2422 describes a malfunction involving the EVAP canister vent shut valve, a critical component of the evaporative emissions control system. The primary role of this vent valve is to prevent fuel vapors from escaping into the atmosphere, ensuring that they are diverted back into the engine to be burned and not wasted. This valve is typically located near the fuel filler neck or within the EVAP canister itself, which stores these vapors. If the vent shut valve is stuck closed, it cannot perform its function, leading to various emission-related issues. This malfunction can also impact vehicle performance, as proper fuel vapor management is essential for optimal operation and fuel efficiency. Understanding the location and function of this valve is essential for effective troubleshooting and resolution of the DTC. Several potential causes could lead to DTC P2422 being triggered. First, the EVAP canister vent shut valve itself may be physically stuck in a closed position due to corrosion or mechanical failure, restricting its movement. Second, there might be electrical issues affecting the valve's operation, including damaged wiring or poor connections that prevent proper signals from reaching the valve. Third, blockages in the vent hoses or connections can impact the flow of vapors, making it seem as if the valve is malfunctioning. Each of these causes needs to be carefully evaluated during the troubleshooting process to pinpoint the actual issue responsibly. Identifying the root cause is vital for implementing a correct and effective repair strategy. When DTC P2422 occurs, there are several noticeable symptoms that may manifest in the vehicle's operation. Primarily, the check engine light will illuminate on the dashboard, signaling that there is an ongoing issue that requires attention. Additionally, drivers might experience poor fuel economy as the engine struggles to manage vapor flow effectively. Another possible symptom is rough idling, which may be caused by the engine working harder to compensate for the improperly functioning EVAP system. These symptoms indicate that the issue is not just a minor inconvenience. Rather, they can significantly impact the vehicle's overall performance and emissions compliance. Recognizing these signs early on enables timely diagnostics and repairs. The first step in troubleshooting DTC P2422 involves verifying the EVAP system status. Begin by turning the vehicle to the on mode to power the onboard systems. Subsequently, you will need to clear the DTC using the Honda Diagnostic System, HDS, allowing you to reset any stored error codes. Following this step, insert the emergency fuel funnel stored in the trunk toolbox into the fuel filler neck. This process helps to equalize pressure or assist in diagnosing the vent shut valve function. Once these steps are completed, it is essential to turn the vehicle back to the on mode and monitor specific parameters using the HDS for further analysis. This method allows for a clear understanding of the current conditions of the system. In the second troubleshooting step, it is crucial to verify the problem's nature. After ensuring the emergency fuel funnel is removed from the filler neck, clear any existing DTCs with the HDS again. Next, start the engine and allow it to idle without load until the radiator fan activates. This step simulates typical operating conditions to gather accurate data. Monitor the EVAP PC duty, which indicates the purge control duty, while holding the engine speed at approximately 3,000 RPM for a minimum of 4 minutes. The HDS will allow you to check if the EVAP PC duty is at 20% or more during this observation. If the DTC P2422 is still indicated as failed, this confirmation assists in duplicating the failure. Contrastingly, if the HDS shows passed, consider the possibility of intermittent faults, which may lead you to inspect connections and hoses to identify more subtle issues. In this step, we focus on the physical checks within the EVAP system. Begin by turning the vehicle to the off lock mode and clearing the DTC with the HDS again if necessary. Next, remove the right front floor undercover to gain access to the EVAP components, specifically the vent hose. Disconnect the EVAP canister vent hose from the EVAP canister to inspect for obstructions or blockages that could hinder vapor release. Now, turn the vehicle to the on mode to check the FTP, fuel tank pressure, sensor parameters using the HDS. The parameters should indicate values between -0.67 to 0.67 kPa. If they fall within this range, it suggests normal operation, but you should still check for blockages in the vent hose or drain tube. Taking these steps will help isolate the problem further and assess system functionality. The fourth step involves a focused examination of the EVAP canister vent shut valve itself. Start by turning the vehicle to the off lock mode to ensure safety, and then carefully remove the vent shut valve from its housing. It is crucial to connect the 2P connector back to the valve prior to any testing. After connecting the valve, turn the vehicle to the on mode and access the inspection menu in the HDS to select the EVAP test and initiate testing of the EVAP canister vent shut valve. Once initiated, check for proper operation and any signs of corrosion that might impede functionality. If the valve operates without issues and shows no signs of corrosion, you can conclude it is functioning correctly and proceed to the next troubleshooting step. Conversely, if the valve is found to be defective, replacement would be necessary to restore optimal system performance. Step 5 involves assessing the integrity of the FTP sensor vent hose. Begin by disconnecting the hose from the FTP sensor to isolate it for inspection. With the hose disconnected, you should again check the FTP sensor parameters using the HDS. The expected values should still be within the range of -0.67 to 0.67 kilopascal. If the parameters fall within this threshold, ensure a thorough inspection of the vent hose to identify any blockages that might restrict proper airflow. Clearing any identified blockages can often solve the P2422 issue. If no blockage is found and the readings are still outside the acceptable range, it may indicate deeper underlying issues, necessitating further investigation into the system components. The final step in this troubleshooting sequence focuses on the FTP sensor port itself. Start by turning the vehicle to the off or lock mode and removing the FTP sensor from the EVAP canister, ensuring that its connector remains connected for testing. Next, turn the vehicle to the on mode and again check the FTP sensor parameters using the HDS. The expectation remains the same, with the values falling between -0.67 to 0.67 kilopascal. If the parameters reflect these values, this indicates that the port is functioning correctly, but it may suggest an internal blockage within the EVAP canister itself, necessitating replacement of the EVAP canister. If the parameters indicate a failure to match the threshold values, this could imply a need for replacing the FTP sensor to rectify the malfunction. Careful attention to technical details during this process is paramount in ensuring a successful resolution. Upon completing all troubleshooting steps and necessary repairs related to DTC P2422, it is crucial to perform a final verification check. Reconnect the HDS diagnostic tool and recheck for any retained DTCs or abnormal readings. This step confirms whether the repairs were successful and that the EVAP system operates as intended. Any codes that persist should prompt a re-evaluation of the components to ensure they were correctly identified and repaired. Confirming correct functionality also involves monitoring live data to ensure that all parameters align with the manufacturer's specifications. This comprehensive check ensures that not only has the immediate issue been resolved, but also that the vehicle is now compliant with emission standards and performs optimally. To prevent the recurrence of DTC P2422 and maintain the overall health of the EVAP system, implementing a strategy of preventive maintenance is essential. Regular inspections should be performed on the EVAP components, checking hoses and connectors for signs of wear, blockages, or corrosion. Keeping hoses clean and unobstructed is vital, as contaminants can lead to significant operational issues. Additionally, using high-quality fuel can help minimize deposits and buildup that could obstruct the system's functionality. It's also advisable to monitor for any warning lights or unusual engine behavior promptly, allowing for early detection of any issues. By putting these preventive measures in place, you can prolong the life of the EVAP system and improve vehicle performance. In conclusion, troubleshooting DTC P2422 involves a systematic approach to identify the various underlying causes of the EVAP canister vent shut valve malfunction. Focusing on each component within the evaporative emission system allows for targeted repairs and ensures that vehicle performance remains optimal. Following the structured troubleshooting steps outlined, technicians can efficiently diagnose the issue and implement effective solutions. Moreover, equally important is the practice of preventive maintenance, which can help in reducing the likelihood of similar issues arising in the future. By employing these strategies, vehicle owners can ensure compliance with emissions regulations and promote a more eco-friendly driving experience. Please like and subscribe to the channel. See you next time.